Right, good afternoon and welcome to the second of our flashpoints and fault lines seminars, the joint minds organised between Rory and Steve. This afternoon I'm delighted to welcome Jean-Baptiste Fressoz, who is now at the Centre National de la Recherche Scientifique, but was formerly at Imperial College. Jean-Baptiste is going to, who is a historian of science and technology, in particular energy, is going to talk about his book, which many of you have seen, more, an all-consuming history of energy, in which he challenges the assumptions of our relationship with energy as one of transition, and looks beyond just power generation and the other much wider uses of energy sources, and recognise that it's a much more complex problem than some wish us to believe, particularly from the political arena. On completion of about 30-75 minutes from Jean-Baptiste, Pipishi and Ollie Morton will act as discussants. Pipishi, who is doctor and lecturer in STEEP, our own department, and Ollie Morton, who is from The Economist, where you are, I've got to get this right, the senior and briefings editors.
Senior editor.
But more broadly, Ollie has been in a relationship with STEEP for 10 years, right from the outset. So welcome back, Ollie, delighted to be here. After that, we'll open up for discussion, conversation, for summaries from our discussion from Jean-Baptiste. And then the bar is open. It's a voucher system, which is in the Phineas bar on the third floor. There are a pile of vouchers there. There will be some before you leave here, take the rest down. The bar is open until the vouchers have been used up, or about 6:15. But I look forward to seeing you all down there afterwards. So without any further ado, Jean-Baptiste, thank you for coming, and we look forward to hearing from you.
Well, thanks a lot for the invitation. Thanks for the claims. Thanks to STEEP for this invitation. The book is a history of energy transition, but not as a historical process. It's more a book which reflects on the ideological nature of this notion, and it's a reflection on the role of history in this idea that facing climate change, we just have to do an energy transition in 20 or 30 years, that we just get out of fossil fuels in such a short period of time. And I think history has played a very important ideological role in the possibility of this very strange future. What started the book project was the fact that history was always, invoked in the current discussion on climate change, even by people who should know. John Koyré, he has been following this problem of climate change since the 1980s, and in the Financial Times he can say that energy transition is the new industrial revolution, as if there were anything similar to the industrial revolution and what we have to do now. And even more worrying, if you take the most official expertise on the topic, namely the last report of the IPCC, of the Group 3 of the IPCC, the group of experts in charge of solutions, of finding solutions to mitigate the problem of climate change, you also have you have a very strange vision of the history of energy. So it's a very big report, over 2,000 pages. Innovations all over the report. Hydrogen is present every other page. All the issues about sufficiency and degrowth are really, really very secondary in the report. But it's when they talk about history that it is even stranger. You can find these very strange sentences. Energy transitions can occur faster than in the past, or a low-carbon energy transition needs to occur faster than previous transitions. But of course, the previous transitions is a kind of mystery. As you all know in this room, we have never consumed as much gas as today, as much oil, as much coal, as much wood. Right now, wind energy is the double of nuclear energy. So we need these old energy sources globally. And if the experts talk about energy transition in the past, it's because there is confusion between the history of technologies and the history of materials. It's a very basic thing to remember, but the history of materials is very different from the history of technologies. And they have this kind of, schema in their head. An energy transition is a substitution of technologies. So this is from the IPCC Group report. And what I just said about energy, that energies are piling up one on top of each other, is not only true for energies, it is true for all raw materials. During the 20th century, humanity has consumed a wider array of material, and each raw material is consumed in greater and greater quantity. So despite all the innovations that occurred in the 20th century, all raw materials have expanded. I just give you an example really to emphasize the difference between the history of materials and the history of technology, and it is the case of lighting. In the early 20th century, across the world, the most common source of artificial light was the kerosene lamp, a low-tech, extremely used technology. Of course, in the 1920s, 1930s, came electricity, a true technological revolution, which rendered kerosene lamps obsolete. But does it mean that oil for the production of light decreased? Not at all. On the contrary, we use more and more oil to produce light because it was used in power plants. Until the 1970s and the oil shock, the consumption of oil in power plants kept expanding. Right now, the headlamps of the automobiles consume more oil than the world in the early 20th century, when most of the people were using oil lamps to produce light. So on the one hand, you've got an enormous technological transformation, and on the other, a much more boring history of materials with everything keeps expanding. If the experts talk about energy transition in the past, it's also because they have probably read part of some of the books that you've got on this slide. And it is true that history of energy is very transitionist. I mean, energy transition is really the key topic in the history of energy. If you take the classic books on history of energy, we have already the same kind of chapters. We've got chapters on the 18th century, which will be mainly about wood energy, about hydroelectric energy. Chapters on the 19th century will be mainly dealing about coal and the steam engine, and chapters on the 20th century will be dealing about oil. But of course, as you probably all know, renewable energies, hydroelectric energy, wood energy keep expanding in the 19th and the 20th centuries. For hydroelectric energy, it's obvious. For wind energy, there is more wind power at the end of the 19th century than at the beginning of the 19th century, obviously. Even terrestrial wind power expanded a lot, especially in the US. At the end of the 19th century, we got millions of windmills in the US, which had a tremendous historical importance because it pumped water in the Midwest and rendered possible irrigation and therefore the expansion of grain production, which was an event of enormous historical importance, probably just as important as the steam engine and the textile industry in Lancashire in the 1830s. But our vision of the Industrial Revolution is obsessed with steam power, coal, and the textile industry, but it's a very narrow vision of the material world of the 19th century, obviously. And the human muscle has also expanded a lot in the 19th and 20th century, thanks to fossil fuels. Thanks to fossil fuels, we got more humans, they are better fed, and they're using much more efficient tools for production. The third reason why experts are talking about energy transition is because historians have not looked at the intersection of the energies. What I mean is that you've got experts or specialists on the history of food, other specialists on the history of coal, and other literature on the history of oil, and all these historiographies do not communicate so much. And in fact, very important things happen at the intersection of these different energies. This is a graph from Anthony Wrigley's book, a very standard text on energy and the Industrial Revolution. And as you can see, according to Anthony Wrigley, wood energy disappears from the British energy system in the mid-19th century. And it is true that in the 1850s in Britain, people would not use wood to warm their houses, and the steel industry had already shifted to coal. But in fact, the British energy system relied more and more on at the beginning of the 20th century, the coal mine in Britain consumed 4.5 million cubic meters of peat crops. To give you a point of comparison, Britain in the 18th century consumed 3.5 million cubic meters of firewood. So just to produce energy, Britain in the 20th century consumed more wood than Britain in the 18th century. And because it is construction timber, it requires much vaster area of forest. We need four times more surface to produce timber than to produce firewood. So in fact, Britain in the 20th century required 6 or 7 times more forest area, if you wish, than Britain in the 18th century to produce its energy. So this is a lot of timber. I mean, this is a picture from Cardiff Harbour in the 1930s, and it is just the pit props for the mines of Wales. So it's really an enormous amount of timber going into the mines. And it is true for all industrialized countries of the 20th century, and it lasts until the 1960s, 1970s, when really coal mines tended to be more mechanized and require less timber. So, and the point I want to emphasize is that in historiography, most of the time, coal is seen as a competitor to wood. But in fact, coal and wood go along very well together. Without abundant timber, in the European countries of the 20th century, they had almost no coal, therefore no steel, no steam, no railways, etc., etc. Timber is not secondary in the energy system of the 20th century. It is absolutely central. So that's why I talk about energy and material symbiosis. You have to really reflect on the relationship between the energies and the materials to understand the real dynamics of the energy system. What is true about coal and timber is also true for coal and oil. I mean, the idea that there is an energy transition from coal to oil in the 20th century is extremely misleading for many reasons, but one very simple reason is that oil is mainly used to power automobiles, and to make an automobile you need a lot of coal. Henry Ford will need 7 tons of coal to make a car in the 1930s, and it is more or less the same amount in terms of weight than the oil that this automobile produces in its lifetime. So automobile is just as much coal technology as an oil technology. And it is even worse than that, because to use oil, you need enormous infrastructure made of steel, because you need tubes, you need to transport the oil, you need to refine the oil, and all this is dependent on and therefore on coal. There are calculations made for the case of Britain in the 1930s. For each ton of oil burnt in Britain in the interwar period, 2.5 tons of coal was required to produce the steel infrastructure and the automobiles which made possible misuse of oil. And once you got oil, coal becomes much cheaper, because a big share of the cost of coal is transportation and distribution. And before the dump truck, the kind of low-tech but extraordinarily important technology of the 20th century, before the dump truck, coal distribution was extremely cumbersome, labor-intensive, and thanks to oil, coal becomes much cheaper, and especially you can distribute coal far away from railway tracks, far away from canals, which is really a revolution of the 1930s. And the same goes with oil and wood. I mean, thanks to oil, you got more and more wood energy in the economy. One of the big transformations of the energy system since the 1960s is the expansion of charcoal. Charcoal, in many respects, is a new source of energy. It is the first time in the history of humanity that you got very large cities, over 10 million inhabitants, using charcoal to cook. Cities like Kinshasa burnt every year 2.3 million tons of charcoal. Paris in the 1860s, which was probably the biggest consumer of charcoal at the time, was only 100,000 tons of charcoal. One city like Kinshasa is probably the consumption of food of France in the late 19th century, of any large European country. And this amount of charcoal is made possible thanks to the truck. I mean, the charcoal is produced in the forest of the basin of the Congo and can travel over 1,000 kilometers before reaching Kinshasa. What is probably less obvious is the fact that you also have an expansion of wood energy in the rich countries, in the rich world, because of fossil fuels. Right now, wood energy is still the first renewable energy in the US or Europe, and quite significantly more important than wind power or solar electricity. On the graph from Europe, there is a line called black liquors. Black liquors is an obscure residue from the production of paper. And it is wood energy. Black liquors right now is higher than solar energy, for instance. And black liquors has expanded because of packaging. So here you've got an energy symbiosis, which is at long range. During the 20th century, and especially after the 1950s and 1960s, you got an expansion of paper production because of packaging. So you've got industrialized economies which are producing more and more goods. These goods need packaging, and this packaging requires paper and therefore consumes wood energy. So the more you've got fossil fuels, the more you've got wood energy. One of the most famous cases of a non-transition in the rich world is Great Britain, and the case of drugs for that. I guess in the room you're all familiar with this example. Drugs right now consumes around 10 million cubic meters of wood, and it is 3 to 4 times more than what Britain used in the 18th century. So after 2 centuries of energy transition, we reached the great result that Britain is burning 3 or 4 times more wood than it did in the 18th century, and just to produce 1.5% of its energy. So once you tell a story like this, the history of energy is not a story of transition. It is the expansion, the symbiotic expansion of all the energies and all the materials. This is really the key and the dominant characteristic of the history of energy. Once you tell the story of energy like this, of course, the obvious question is, where does this very strange idea of energy transition come from? What is its intellectual genealogy? First of all, you have to notice that it is a fairly recent notion. During most of the 20th century, experts talked about the dynamics of energy, and they never talked about energy transition. This is an instance of that. I mean, this is a futurology proposed by a proponent of solar energy in the US in the 1970s. And as you can see, according to him, everything will grow. Solar energy will grow, obviously, but coal will grow, nuclear energy will grow, oil will grow, gas will grow, etc., etc. There is room for all sorts of energies. The future is seen as a bigger present, not as a radically different present. We don't imagine massive shifts in the energy system, just an expansion of everything. And this is very dominant. I mean, if you look at conservationist literature in the US in the 50s or 60s, they ask questions such as, will there be coal in 2 or 3 centuries? Which is a testimony of the fact that we do not imagine, getting rid of coal in a short period of time, right? There is one group of scientists who starts imagining the future in a different way, and they are atomic scientists. Most of them have participated in the Manhattan Project, and most of them are obsessed with one particular kind of technology, which is the breeder reactor, a specific kind of nuclear reactor which opens a kind of infinite energy horizon. You can have energy for not centuries, but millennia. And that changes everything. The first person to use, to my knowledge, to use the word energy transition is Alexandre, a nuclear scientist from the Met Lab in Chicago during the Manhattan Project. Then he moves to Caltech, and he had also a very important role in the early study of climate change. And we'll come back to that later. And Harrison Broad used the word energy transition because actually it's using a word of atomic physics. You know, nuclear transition first, and basically it was first a change of the electron around its nucleus, and then he recycles this phrase to talk about the future of energy. And he mixed that with the idea of a demographic transition, which came from Kingsley Davis, a sociologist of the 1940s. He's also part of the new mass fusion intellectuals, which are very important for early environmental thinking in the US in the 1950s and 60s. And of course, these intellectuals were very interested in this idea of demographic transition. Another important intellectual in this idea of energy transition is Marion Kim-Hubbert, the theoretician of peak oil. I mean, I think the graph, the lower graph, has been of very great importance in this idea of energy transition. According to him, there will be an energy transition in the far future. I mean, all fossil fuels, coal and oil, have this kind of peak shape because it is contrasted with the infinite energy plateau which you can reach if you build a bigger reactor. But if you pay attention, the end of fossil fuels, according to Marion Kim-Hubbert and his colleagues, you know, it's like in 4 or 5 centuries. So the energy transition, when it was first imagined by atomic scientists of the 50s, they saw it as a very slow process. And it's a process that will be driven by the exhaustion of fossil fuels, and therefore by the rising price of fossil fuels, which will make nuclear energy competitive. And at the end of the day, in 4 or 5 centuries' time, nuclear energy will prevail with breeder reactors and hydrogen. And what I think was a kind of scientific scandal was the fact that experts have recycled this idea of energy transition, a very strange futurology, a very heterodoxical futurology, coming from atomic scientists obsessed with the exhaustion of fossil fuels and imagining the future of humanity across millennia. Look at the scale of the X on the horizontal axis. You know, we are recycling this futurology to reflect on climate change, which is a very different kind of crisis. I mean, for climate change, we don't have to do the transition in 4 or 5 centuries. We have to do it in 4 or 5 decades. We have to do it in a context where fossil fuels are cheap without the incentive of scarcity. So it's a very, very different situation. Nevertheless, we use the same kind of strange futurology. So why is that? Well, it's mainly because in the 1970s, there were both the energy crisis, which became a very important theme in the US and elsewhere, and the issue of climate change. If we all talk about energy transition right now, it's probably because of this guy, Jimmy Carter, who in 1977 made a famous discourse about the energy transition. He was commenting on this graph, which is a very, very original way at that time of describing energy dynamics. The trick is to put everything in shares, in relative terms. If you put wood, coal, and oil in relative shares, you can see a dynamic of transition. But when I say it is original, it's because at that time, most of the time, people were representing the dynamics of energy with this kind of graphs. This idea of energy transition became popular at IASA, a very important research center, which made global modeling of energy and which will play a very important role for the IPCC Group 3. And we'll come back to that perhaps later in the discussion. So it was getting popular among experts, and it was also very popular in the oil industry. I mean, there's a very interesting discourse given by Edward David was the head of R&D of Exxon in 1982, a climatologist, who explained that climate change is real, but the key discussion is, will it be catastrophic before the energy transition happens? And it's quite astute to present the thing that way, because climatologists themselves, the proponent of the warning of climate change in the late 1970s, they also see energy transition coming in 4 or 5 decades. You've got articles, papers from the late 1970s explaining that climate change will have economic consequences at the beginning of the 21st century. It will become catastrophic in the middle of the 21st century, but that leaves enough time to make an energy transition, because everybody knows that energy transition takes 50 years to happen. All this everybody knows. Actually, nobody knows how long it takes to make an energy transition. We have never done one. I mean, we really don't know. Right? And energy transition really became popular during the energy crisis in the 1970s as a kind of solution to the energy crisis. Energy crisis becomes really a very common phrase. Energy transition at that time, in the 1970s, designates more or less any kind of energy that increased the energy sovereignty of the rich world. So it could be coal, for instance. Coal will be an energy of the energy transition in the 1970s. And what's happening is that the same experts working on the energy transition, in the energy crisis, became the first experts to work on the climate crisis. And the most famous case is probably William Nordhaus. William Nordhaus, Nobel Prize for his work on climate change in 2018. In 1973, he writes a paper about the energy crisis, explaining that oil is becoming more expensive. Does it mean that we need to restrict our consumption of oil? Not at all. On the contrary, we need to extract oil now. Why it is expensive? Because perhaps, probably, at the end of the 20th century, oil will become obsolete, thanks to the breeder reactor. I mean, the breeder reactor plays an important role in the Nordhaus early articles. 2 years later, he writes the very first paper from an economist on climate change, and he said there's an issue about the greenhouse effect. Does it mean that we need to tighten our belts? Certainly not, because it would be so much easier to do the energy transition in a few decades at the end of the 20th century when we have the breeder reactor. So energy transition was really a key topic in the energy crisis, and because it is the same kind of expert, the same institution, the reasoning on scarcity and energy transition shifted from the energy crisis to the climate crisis. Whereas it shouldn't, this should not have happened. And then, of course, energy transition is, it's very comfortable for the government. And it is quite clear when you look at the archive of the US government that the technological blah blah about energy transition was a very powerful way, a very powerful delaying tactics for the US government. In 1988, as you probably know, the IPCC was founded. The key letter in the acronym is I, for intergovernmental, not international. Why? Because at that time, there was already a group of experts, mainly climatologists, natural scientists, working on climate change. It was called the Advisory Group on Greenhouse Gases. It had been set up in 1985 by UNEP and the World Meteorological Organization. And for this group, it was quite clear that we had to act right now. And in 1988, there was an important conference in Toronto, in Canada, where the final declaration is extremely ambitious. It states that we need to reduce our emissions by 25% before 2000, or 2005, sorry. To do that, you need to put a carbon tax in the rich world that will finance development and adaptation in the poor world. When the US government heard about these fantastic proposals, he said, right, we're not going to leave a bunch of bureaucrats from the UNO and environmental scientists dictate our energy policy. And we need a new institution, and it will be the intergovernmental institution. And the archive is quite clear that in this IPCC, we need to have representative not only of the Minister of Research or Minister of Sciences, we need to have representative of the Ministry of Energy, Agriculture, Industry, like serious people. When the IPCC was created, there were 3 groups already. The first group was headed by a British scientist whose name escaped me right now.
John Hamilton.
Thank you. The second group was headed by Yuri Israel, and the third group was headed by Bernard and then Robert Einstein. Interestingly enough, Robert Einstein is openly climato-skeptics. It might seem strange that the president of an IPCC group was climato-skeptic, but Yuri Israel, the president of the group 2, was also climato-skeptics. Robert Einstein is also the chief negotiator of the US government at Rio in 1992. And he takes his order from John Sununu, who was chief of staff of George Bush. And when you see the discussion, it's quite clear what is the status of energy transition in these international arenas. I mean, we should not be shy about saying that it was thought as perfectly rubbish. John Sununu told Einstein, okay, at Rio, we're not going to commit on certain emission targets, no targets. We're not going to pay for energy development in the whole world. Basically, it's what climate change is about that. It's about international relationship. So no money, no target, play the technology card. And it made perfect sense for the US government and many other governments in the world, to really put forward the ability of technologies to solve the issue. And play the technology card is exactly what IPCC Group 3 has been doing since the 1990s. If you look at all the 6 reports, technological discussions are overwhelming. I mean, all these reports are mainly about technologies. For instance, in the 27 report, there is a discussion about the fusion reactor. Not only the fission nuclear reactor, but the fusion reactor, explaining that by 2050 there will be commercial fusion available. In the last report, in the 2022 report, there is also a paragraph on the Hyperloop, this fantastic train imagined by Elon Musk, like maglev, traveling at 1,000 kilometers per hour in tubes where void will be made, like rubbish technologies, crazy proposals that are in this report. And probably the most troublesome story is about CCS, carbon capture and storage, and CDR, carbon dioxide removal. After writing the book, I wrote a little bit of the history of this technological proposal. CCS and CDR was pushed very early on by the fossil fuel industries until the 21 report. It was not regarded seriously by the experts of the IPCC Group 3. They explained that coal electricity with CCS would be more expensive than nuclear electricity, so there would be no point at all in putting up CCS. And then there is a 2005 report by the IPCC, by the Group 3 of the IPCC on CCS, a special report on CCS, which suddenly makes CCS, palatable. It's not that expensive. There are huge reservoirs where you can dump CO2, liquefied CO2, and then CCS literature boomed. And in the last 2 reports, the 2014 report and the 2022 report, CCS and BECCS, so it's bioenergy with CCS, an even crazier proposal, plays an enormous role in the carbon neutrality in all the scenarios of IPCC Book 3. So really, I think the expertise on solutions has been far too focused on technologies and on high tech. And the problem is that, when you look at not at the net zero scenarios, which is this on the right hand side, but on the prospective scenarios of the International Energy Agency, but they don't see any energy transition coming. Right? They imagine coal decreasing a little bit, but oil and gas are still either stable or expanding. And it should not come as a surprise. Energy transition is a radically strange idea. It is a fantastic future. The future that was born out in the 1950s during the craze about the atomic age. It was recycled in the 1970s as a solution for the energy crisis. And then this expertise was transferred into the climate problem for no good reason, for no good scientific reason. So just to conclude, I would say that the energy transition projects a non-existing history onto a useful future. Thank you for your attention.
So, thank you very much, Jean-Baptiste. Now I'll ask if you'd like to go first in response, and then over to Ollie.
Well, thank you very much. I think I really enjoyed reading the book first, and obviously listening to this amazing, wonderful presentation. Actually, thank you very much for really taking us through the history. And it is actually quite an eye-opener for me when I was reading the book as a transition scholar. So I have really studied transition for the last 10 years or so through my PhD postdoc, and still I do study transitions, not necessarily energy, and let me come to that, because I think I have seen in the last decade the kind of evolution of transitions as a interdisciplinary and transdisciplinary field. So I will maybe reflect on my position as a transition insider, if I may call myself that, and then really reflect and really take in, almost take in the historical perspective that you bring in here. So what I wanted to kind of start with is obviously that transition itself, or socio-technical transition itself as a field in the last 20 years or so has really evolved from the early on, from the early kind of definition of technological transition or technological change into more socio-technical, into more this co-evolutionary aspects. And you mentioned Frank Hills in the book, and that has been quite a pioneering work in the early 2000s, where the idea of co-evolution between social and technological has been put forward as part of this, looking at these change processes. But I think what has also kind of happened in the field in the 20 years is really broadening the spatial scope and the normative scope of transition. So you look at history of transition, which is the more kind of temporality of it, but what maybe I will focus on is the kind of spatiality and also the where is it? So is it what direction, transition to where? And that's where a lot of debate around justice, a lot of debate around decoloniality has come into the very vibrant conversation in transitions literature. So for example, when I think about energy justice, which is a very, very sort of heavily debated topic at the moment in the transitions literature, I can say that when we think about overconsumption, which is actually in the title of the book, which then makes me think about demand, energy demand, and to what extent we can really sustain by consuming more and more and more. I then digged up into the kind of history and the current state of energy access. And actually 3 billion people in the global south lacks sufficient energy for a decent standard of living at the moment. And less than 10 gigajoules per person per year is available to 38% of the global population at the moment. So this is a 2022 study, so quite recent. So basically, this is to say that a huge majority of the global population at the moment lacks sufficient energy, and what is sufficient energy is indeed to say that it is linked to well-being, it's linked to decent standard of living. So this is really to reflect a bit, kind of take a step back and to think about when we think about energy demand, when we think about sufficiency and demand management, which is a very important agenda also through IPCC and also through modelers at the moment. How can we really think about demand side when at a global scale? Because demand side, thinking about demand side at a global scale, would mean that we need to, because in the modeling, even in the modeling world, there is actually kind of a ignorance to the minimum threshold of energy needed for human well-being. So even within the modeling community, there is a lack of consensus around what is the minimum energy need, and that is needed. And then there is inequality in distribution of that need. So some obviously there is a huge proportion of population who is using maybe, and both household and industrial, there's more consumption, but at the same time, how do we redistribute the energy that we have at the moment? And when we think about energy demand, we also have to think about rebound effects, right? So it's about, when we save energy, so industrial demand, if you think about, okay, can we make our industries more energy efficient, then of course, from an economic perspective, the idea would be that, okay, with that energy efficient technology, can we produce more? Can we maximize more profit? Can we actually, that is a cost minimization. So energy efficiency enhancement is actually a cost minimizing technique to a lot of industries. So they would just produce more, and that lead to a kind of a rebound effect. So in reducing energy demand, so if we have to think about the future of energy, energy transition, so reducing energy demand is actually a very kind of a political and governance question. And that leads me to the kind of final point, which is policy. Because I feel that, because you mentioned policy mixes quite a lot in terms of the history of energy, and indeed, I feel energy transition is not a story of substitution, as you rightly showed, and there is this X curve which comes from a lot of research by Kills and colleagues, who looks at the kind of change processes as the niche development and the destabilization of regimes, which is also in the book. For those of you, I think it's in page 135. You will see that in the center there is this idea of reconfiguration. But actually the X curve shows substitution, while reconfiguration is actually another pathway. And current studies show that reconfiguration is actually a more kind of practical way to think about energy evolution or transition rather than substitution. So substitution is actually not the way to think about energy mixes. So then how do we think about the future of energy mixes, future energy symbiosis? And I think policy has an important role to play in accelerating that energy, future energy mixes in the right direction. So a lot of the work, not within energy policy. Again, you mentioned the kind of the connection between energies, but I would go one step further into saying there are connections between systems. So energy system is deeply connected to mobility, health, housing, food and agriculture, and so on. So looking at all those societal systems as interconnected and coupled really makes the situation much more complex when we think about energy demand and energy use. Because on one hand there is lack of access, there is injustices. And injustices are actually multi-systemic, so you kind of reduce energy in one sector, and then you have broader repercussions. You have repercussions of health injustices, so you reduce energy and you have health poverty and you have food insecurity, for instance. So how do you think about that, those indirect effects of energy, reducing energy demand? So a question there would be that how can we think about the role of policy? And by the way, IPCC's role is indeed to shape that policy, at least the current cycle. It was very much around how do we shape policy in the right direction across multiple systems. And I'll start by asking that really fundamental question that really intrigues me every day, which is where, I mean, we are told that to learn from history, and as you showed in the book, that history doesn't tell us much about, how we really have to think about the future, the kind of imagination and the visioning we need to do about the future. So if we really want to kind of learn from history, what does this mean in terms of all the climate urgency that we see? What does it mean in terms of shaping the future? So if you're really learning from the history, then are we over-determining a hopeless future? And if not, then what are the kind of ways to not overplay the role of history, and really what are the different other mechanisms, other drivers, other inspirations we should be looking at in order to really shape the future that we want? Thank you.
Okay.
If you want to come back on any of the points, we'll pass you to just.
There are so many points I
if you want to make a short response,
sure.
And then we'll hand it short.
Okay, just briefly. About transition studies. I took it as a useful target to be here. It's because, the C sentences in the IPCC Group 3, where transition can happen faster than in the past. What they quote as a reference is all the transition, not all, part of the transition literature, papers from Frank Hills and Benjamin Zobacco. So I think it's the only way where we talk about history in the whole 2,000 pages report, and it is to say very, very strange things based on work by sociologists who have perhaps a vague notion about the history of tech. So that I thought it was quite useful because it was the way history was understood by the experts, and then it gives the very strange declarations by John Kerry and others. Basically we have to accelerate the energy transition. It's a much deeper problem than that. So I think it was a good example of the kind of manipulation of history and how a wrong history can tilt all the discussion towards one path. Of course, it's not the fault of transition studies if hydrogen is all over the place and CCS and CDR. I completely impressed. I'm not blaming transition studies for that. And there are plenty of other reasons for this. But I just want to clarify my position compared to transition studies. Then about rebound effect. I mean, the whole book is a lengthy gloss on Jevons paradox, obviously. But Jevons was, he was obsessed with coal, and he thought that Britain had shifted to coal because of scarcity of food. It's actually more complex than that. And because of coal, Britain has access to much more wood and required more wood during the 19th and 20th centuries. So it's a kind of generalized Jevons effect. About policy, I mean, if I had the answer, honestly, I would try to do politics or whatever. No, but to be clear, history just can only feed gloom. And I think it's quite honest to say that history has no positive discourse to propose on the public sphere on this issue of energy transition. I mean, the fact that it's not just energy; it's all raw materials which are expanded. In 1928, there is a forester, a U.S. forester, saying that he sees the skyscrapers made of concrete and steel, and he said, "Don't worry," to his forester colleagues, "raw materials are never obsolete." And this prediction was perfectly true. I mean, it's completely valid. It's really what has happened in the 20th century. I think the question of equity should be central, whereas it is not. I'm not obsessed with the IPCC Group 3, but when you look at the net zero scenarios, there is no transfer at all between the countries. And they say that, I mean, we are just modeling technological development. It's in what we call Pareto optimality situation. So this should be a key issue if we wanted to have a more serious discussion on climate change. And it's not the case, in part because we are endured by technological solutions.
Thank you. Ollie, the floor is yours.
Oh, thank you. Or the sitting above the workshop here. I had the great privilege of reviewing this book, before coming here, I look back over both the review I originally wrote and the review that was published, and they both seem pretty favourable. Though slightly different in interesting ways we might get into over a drink. I thought that this book was definitely for me, one of the books of the year last year, and I thought it was scandalously under reviewed in Britain and America. I don't know about in France. But I have noticed recently a few things that have suggested to me that at least some people who are paying attention have been reading it. I recently participated in some discussions about nuclear fusion, where I made some references to some of the insights of Jean-Baptiste's book, and afterwards got a note from a very senior energy NGO person in the United States, saying that book had completely overwhelmed his thinking. I also recently heard a colleague saying that we were going to run a large piece about charcoal in Africa. And I said, oh, you should read this passage in Jean-Baptiste's book about charcoal. And I said, no, it's already in that, don't worry. We've already paid attention. So I hope this idea about what a full, I was going to say the true history, but I try to avoid that, a fuller history of energy and materiality that's seen through the lens of technology in use, not technology as innovation, which is, I was going to say it's a particular problem both with some technology studies and also very much with media representations of technology, which is always about innovation. See media stories about small modular bloody reactors. Passive. So I think it's wonderful the book's out there, and I think it's been doing. I think it is doing good. I think another thing that's sort of like a meta point about it is the fact that it reminds people with a background in an interest in history that historical representation and to some extent historiography actually really matters. It actually matters to political and economic choices, how people choose to or are allowed to see the past. It also makes a secondary point about history of technology. Technologies that don't happen still matter. The role that fast breeders play in chapters sort of like 6, 7, 8 of the book is really fascinating, considering that there are no fast breeders. But the degree to which that idea of the unlimited energy future and the need for a transition to it underwrote ideas like Harrison Brown's is just fascinating. The other point, as Jean-Baptiste said, that this book is to some extent a long and, I must say, also extremely entertaining gloss on Jevons, also points out these ideas of exhaustion and replacement as being a primary way of thinking about the world that goes back to, well, Jevons actually doesn't talk much about replacement. There's some gesturing. And for me, the classic example is Crookes in 1897, talking about the depletion of nitrogen reserves and the need for artificial nitrogen. And one of the charts that you just showed of sort of like coal going up and down and then nuclear taking off. That's exactly the sort of thing you see when people start talking about the advent of artificial nitrogen. And you see the same thing, of course, in Hubbard, who turns up in two different parts of the narrative in this book. This idea that there is the exponential, there is the inflection, there is the saturation curve. These ideas about how the future might look. I'm particularly interested in something that I would love to find out if anyone is working on. One of the things that Cesare Marchetti is using when he's looking at energy transitions are the Lotka curves from ecology about predators and prey. And of course, Lotka is also a theorist of global environmental change, and how he thinks about these two things, I would love to learn more about any interplay, particularly actually between Lotka and the technocracy movement. All that said, the other half of my remarks is about the particular context in which I read this book, because I first came across Jean-Baptiste's book and indeed Step when I was writing my book about climate geoengineering, The Planet Remade. Well, actually about all geoengineering, The Planet Remade. And thinking about the use I put some of his other work to in that book makes me see a continuity that I find intriguing. I thought I'd share with you. The previous Jean-Baptiste's previous book was translated into English as Chaos in the Heavens. It's Le Vol du Ciel. Yeah. And this is a wonderful re-examination of the history of thinking about climate change. And it looks like, oh no, I thought you were going to say, and I have a copy here, but no, you were just getting a glass of water. It's a wonderful retelling or reimagining, unearthing of histories of thinking about climate change that makes very, very clear the idea that the fact that the idea humans have an influence and a modulatable influence on the climate is actually a given through most of modern history. It's there in various ways. It's got a strong role, as we also see, I think Jean-Baptiste and Richard Groves would see this in different ways, but there's a strong role in colonialism, in thinking about colonial climates and the ways in which climate optimization legitimizes various forms of colonial activity. And the idea that this idea of, by a strange coincidence, but also I think an instance of what Jean-Baptiste and Sommer calls l'inconscience modulatrice, this idea that it's at exactly the time that people start changing the climate that they stop thinking they can change the climate. So it's around the 1880s. And the idea of the sort of things that climate used to explain are now being explained by anthropology and sociology and indeed even genetics. And the idea that people are influencing the climate is similarly downplayed. So as someone interested in geoengineering, that knowledge that the world used to look like that, and that the modern world in which it's thought that the natural and the human technological are so sharply divided is a creation of late 19th, early 20th century thought. That's very powerful. Another link between the two things is just that the cast of characters, for me reading the second half of More and More and More, so I guess that would be the more and more half, I was fascinated by the degree to which it was almost like old homing for me, because I kept meeting people I'd read about before in other contexts, like Hubbard, like Harrison Brown, who, among other things, caused Charles Day Keeling to start measuring carbon dioxide, and adapted Davis's idea of demographic transition into energy transition. And Steve Schneider and Cesare Marchetti, who actually coins the term geoengineering in its modern use, and Ravel and Arnold Grubler, and these people are sort of like been part of how I thought about that. And so it was really lovely to just sort of like see them all occasionally with pictures, and I love that. But it made me realize the extent to which the way that we write the history of climate change writes out sort of like weird things like Harrison Brown saying, how about we increase the level of carbon dioxide by a factor of 10 in the atmosphere? Because that would really help us feed everybody. And this sort of thinking, this sort of unlimited atomic scientist, atomic Malthusian thinking, is absolutely there in the history of what is now read somewhat as the counter history of climate engineering, and also the history proper of climate change. So finding all those those commonalities is wonderful. And the last point is, of course, that as someone who, since writing the book, which is not a plea or a case, but it is an examination, I've become involved. I'm the chair of the trustees of a charity which funds research into the potential impact of solar geoengineering in the global south, researchers in the global south researching those subjects. And so I have maintained an interest in the sort of policy discussions around this, and I have developed through that process a quite deeply held skepticism for the notion of the socio-technical imaginary, because I just got fed up with being told that this was a socio-technical imaginary, and somehow the sort of things we see in articles that quote John Kerry, in which there are green hills covered with wind turbines and beautiful solar panels, is not a socio-technical imaginary. So I felt that although I'm absolutely sure that you don't mean the book in any way as a vindication of geoengineering, I'm very pleased by the point later on saying it's all very well to mock the supposed techno-solutionism of engineers, but the normative positions on climate that prevail in the social sciences are even more ridiculous. I felt it ignoble, but genuine thrill of pleasure. That's it. So thank you for that and for much else, because it really is a magnificent book. Well, you have to now hold this and pass it to whoever you want to speak.
Okay.
Just like if I were well, I had that vision of John Kerry looking at hills and Don Quixote paddles, windmills and paddles. Does anything like come back from?
Well, there are many different points. Thanks for making the connection with my previous works. Long time ago, around the year 2000, I started a book which will be published later in the title Happy Apocalypse.
Mm-hmm.
And it was really to say that we should not tell the history of the environment as a kind of growing consciousness of the problems in many domains. It's really the opposite that happens. And I can give you the example of pollution. In the early 19th century, pollution and environmental change were seen as extremely dangerous because the environment was a key topic in medicine. Medical causalities, if we were all if we all got the disease at the same time, here, it's not because we have passed over the microbe, it's because there's something in the air, in the place, in the water, in the environment. And in this medical imagination and theories, of course, pollution was extremely important and complained and protested against. So what happened was rather the creation of a kind of disinhibition. That's the word I used at that time. And the book on climate, the same thing. Indeed, climate change had been a huge issue in the 18th century in particular, and it was not the same as today. It was more connected with deforestation and the cycle of water. I cutting down forest to after the cycle of water, which was a providential cycle. It was on the Earth because the Earth was a creation, and of course, changing the creation could have a significant impact on the well-being of humanity. And then how all this knowledge was kind of sidelined by both scientific advances, like the Ice Age theory, for instance, which imagined, we realized that in the past there had been massive climate change where obviously humanity was not responsible for these enormous changes. And second, core technologies, the railroad and also technologies which make famines not so important for Western countries after the second part of the 19th century, and which makes climate change not such an issue. And I think it has a role in my story as well, because I've already talked about that, but why basically we have done nothing about climate change since we know about it, and it's been a long time now. It's mainly because we are convinced in the rich world that we can adapt. And I think that's really the key factor. And I found interesting account in the Thatcher cabinets. In 1989, Margaret Thatcher asked the minister, what can we do about climate change? And each and every minister says, what could we action? And the transport minister said, of course we could develop public transport, but are we sure that people will really stop using their cars? Not of this at all. The only thing you could do that would be efficient would be to increase taxation on fuel, but you don't want to do that probably, right? And it's all the same for every sector, every minister. And in the end, the energy minister, if I remember correctly, saying that, Britain is just 2% of the emission in 89, it would be even less in a few decades. So the only thing that we can hope is in the adapt. This is 89 in Britain. In the US, they had the same discussion in 1976. And why we can adapt? Because we've got fossil fuels and we've got modern agriculture. Agriculture was seen as the key sector, the sector that will be the most impacted and the sector which is obviously the most important for the survival of the population. And basically the agronomists that are consulted and seriously consulted, I mean, not so much in 76, but in 81, says, the US can sustain a 3-degree warming because we are more dependent on fertilizer, greenhouses, the fact that
Actual
greenhouses, yes, the fact that agriculture is not so much dependent on climate, e.g. the greenhouses, it's kind of weird argument sometimes, is very powerful to understand, I think, the fact that we don't do much. And of course it was very cynical because they had perfectly clear understanding that it would be more difficult for other countries also. So there is a connection between the climate book, the chaos in the Netherlands, and this book. There's a continuity here. Well, I will stop here because I don't want to.
Thank you.